Welcome to solverfy.
Approximate the 8th root of 500 to 8 decimal places by using Newton's method. So the formula for Newton's method is that x sub n plus 1 is x sub n minus f of x sub n over f prime of x sub n, where f prime is the derivative of the function f of x. So first we want to define our function f of x. We want to approximate the 8th root of 500. So we're looking for x equals the 8th root of 500. We could raise both sides of the 8th power. That would give us x to the 8th equals 500. And we could rewrite that equation or this expression as x to the 8th minus 500 equals 0. So we're just looking for the solution to this equation. So one thing we could do is that we could write this as a function. F of x equals x to the 8th minus 500. We're just trying to find the zeros of that, and we could show graphically that this is a continuous function. We would have a y-intercept at negative 500, and we know that it would be an increasing function. So we know it's going to have a 0. So we can use Newton's method to approximate that. We just need an initial guess. That's our x sub 1. And we'll guess 2. We'll let 2 be our first guess. And we can prove that that's going to be a little bit too small, because if we do 2 to the 8th minus 500, that gives us, let's see, 2 to the 8th minus 500. That gives us negative 244. So that means 2 is a bit too small. So we can use Newton's method to close in on that point right here to estimate that 0. So we're going to need the derivative f prime of x. So the derivative of x to the 8th, we'll get you the power rule. We bring the exponent down to 8x, and then the 8 goes down to 7. So 8x to the 7th is the derivative. Okay, so now we're ready to start using Newton's method. Let's find the second x, or x sub 2, using the formula. That would be x of n, which is 2, minus, and then we would do f of 2 over f prime of 2. That would be 2 minus f of x is x to the 8th minus 500, so it would be 2 to the 8th minus 500 all over 8 times 2 to the 7th. And if we plug that in the calculator, we get about 2.2382125. That's got that to 8 decimal places. And now let's find x sub 3. That would be that previous x value, 2.2382825, minus f of that value. So we would plug that function in, or that value in, to f of x. So 2.2382825 raised to the 8th power minus 500 over 8 times 2.2382825 to the 7th power. And if we plug that in the calculator, that gives us approximately 2.18055972 if we round that to 8 decimal places. Let's go on and find x sub 4, and we're looking to see where we get these the two x values the same to 8 decimal places. That's when we can stop. So the fourth one would be 2.18055972 minus 2.180555972 to the 8th power minus 500 over that same x value, or 8 times that value raised to the 7th power. And that gives us the fourth x value to be 2.1 5. See, 2.174661675. Yeah. Okay. So let's go on and find the fifth one. X to the fifth would be that same X value minus that value plugged into the function. Should be a 5 there. And then that value raised to the 8th power minus 500 over 8 times that value raised to the 7th power. And that gives us the fifth value to be 2.174559928. Okay, let's find the sixth one. X sub 6 would be that value minus that value plugged into the function. So 2.174559928 raised to the 8th power minus 500 over 8 times that value raised to the 7th power. That gives us the 6x value to be 2.174559928. That's exactly the same as the fifth value. So this is the correct solution to 8 decimal places. So the 8th root of 500 to 8 decimal places is about 2.174559928.